when we did our last part of the lecture, the first part of these notes, we are just doing the units, the amounts of elements. Now what we're going to do today is we're going to talk about if you have a compound. And there's a little bit more complicated because if you're looking for an element, you just look it up on the periodic table. If I want to know copper, I look on the periodic table and it says, oh, 63.5. That's what 1 mole weighs. That's its mass. That's how many atoms. No problem. But now what if we have a compound? It's not really difficult. But what you have to do is you have to find the mass of the compound. So what we're going to do is I'm going to show you how to find the molecular mass if it's a molecular compound, 2 nonmetals, or the formula mass if it's an ionic compound, okay? So the molar mass of a compound is 1 mole. So really all you're going to do is kind of like we did with elements, but you're just going to add them up, okay? So the molar mass of a compound is the sum of the atomic masses of each atom in the compound. In other words, I take each element I have, how much of each element I have, because that's a subscript, and then I multiply by mass on the periodic table and add them up. So basically, you're just taking the individuals, putting them together, and adding them up, okay? So if I'm trying to find the molar mass of carbon dioxide, all right, I have 1 carbon, I have 2 oxygen. So what I'm going to do, 1 carbon, and this 12 comes from the periodic table. So the mass of carbon in this is still 12. But oxygen, I have 2 of them, okay? So 2 times 16 is 32. So when I add these 2 together, I get the mass of carbon dioxide is 44, okay? So you can't just look it up in the periodic table. You gotta, this is pretty easy math here. So there's 1 carbon, that's 12. There's 2 oxygen, 2 times 16 is 32. Add them together and you get 44, okay? What about aluminum carbonate? And again, whenever you have something in parentheses, you have to multiply everything inside the parentheses by that number. Aluminum would still just be 2. You don't multiply because it's not in the parentheses. This is 3 carbon and 9 oxygen, okay? So if I'm doing that, okay, I got 2 aluminum, 2, and again, I would round this to 27, so it's 54. This is from the book, so it's exacts, but don't worry about it, you guys. We're okay. We're just doing, rounding. It's fine. Okay, carbon, 3 carbon at 12, so that's 36. 9, because we got 3 times 9. 9 times 16 is 144, okay? So I've got the individuals and then I just add them up. So I get 234, okay? So when you're trying to figure out the mass of a compound, what you need to do is what elements you have, how much of each of that element, multiply by their mass from the periodic table, and add them together. Okay, that's all you do to find the mass. So it's one more step. Obviously, it's easier doing an element. You can just look it up in the periodic table. You're still going to have to look them up in the periodic table, but now you're just going to have to add them together. Okay, your turn. Molar mass of, okay, so we'd have 3 nitrogen, 12 hydrogen, 1 phosphorus, and 4 oxygen. Okay, my guess is 149. It's not a guess, I just did this one. Okay, so how did I get that? Nitrogen, 3. So 3 times 14 is 42. Hydrogen, there's 12 of them, but hydrogen is great because it only weighs 1. I didn't even use my calculator for this one, guys. Phosphorus, there's 1, so that's 31. And then 4 oxygen times 16, and then just add them together. That's where I get the 149. And again, you guys, you don't have to use 149.12. Unless you want to. It's your choice. Okay? Okay, this one again. I have 1 magnesium, I have 2 chlorine, and I have 8 oxygen. Okay? So magnesium, 1 times 24. A lot of people for magnesium use 24.3 because it's kind of, a third of. Again, it's not a big deal. Chlorine, there's 2 of them. Chlorine, you do use 35.5. It's one of those you don't round. So you get 71. There's actually 3 of them you don't round, you guys. Chlorine used 35.5 when you're figuring out the mass. Copper used 63.5. And mercury used 200.5. So those 3, when you're figuring out the formula mass of something, you got to use 0.5s. Their isotopes fall right in the middle, if you remember when we figured out masses of isotopes. So chlorine, copper, and mercury. I don't know if you want to mark those down, but those 3 you use 0.5s. Okay, so 71, and then 8 times 16, because there's 8 oxygen, and its mass from the periodic table is 16. And again, this numbers all come from the periodic table, you guys. Add them together and you get 223. Okay. Okay. So we can use these now because before we were converting moles to grams of elements. Well, we can do the same thing for compounds. We just had to find their mass first, okay? And if you remember from this slide, the mass of magnesium chlorate is 223, okay? We're going to need that again, okay? All right, we're going to calculate the mass of 1.5 moles of magnesium chlorate. All right, so we're starting with moles, so we're going to put 1 mole on the bottom, and we're going to put the mass of chlorate on top, 223. So, and again, when you guys do this, you don't have to do this plan thing. What I'm looking for is this, the calculate. Okay, so you take your 1.5 moles of magnesium chlorate. That's what we know. Okay, moles on the bottom. I want them to disappear, so I want moles bottom. And 1 mole of this has a mass of 223. 1 mole of any compound is whatever its molecular mass is when you add them all together. So I'm just going to take 1.5 times 223.2, and again, we'd probably use 223, and you get 33.5. So it's like we did before with elements. Now we're just doing them for compounds. Okay, use the molar mass of this one. We're going to do 35 grams of water. Okay, and water has a mass of 18. Hydrogen is 1, and there's 2 of them, plus oxygen 16, so it's 18. Okay, so again, this is what I'm looking for, this part. So write down what you know. You have 35 grams of water. Okay, now I want to get rid of grams, so I'm going to put 1 mole on top and 18 on the bottom. And again, it's just adding these together. Water is one we use a lot, so you probably should remember its formula mass is 18. Okay, so 35 divided by 18, 1.9 moles. That's how many moles. And again, this is just like multiplying by 1. It's a conversion factor. Okay, so I converted grams to moles. Okay, so same thing we did with elements, now we're just doing it with compounds. Okay, if I wanted to figure out the number of molecules, same deal, only now I have to do another step. If you go from grams to molecules or molecules to grams, you have to do 2 steps. Kind of like if we're changing years or minutes into years or whatever. I don't know how many minutes there are in a year, but I can figure it out by going hours to minutes and so on. So sometimes you need more than one conversion factor, but again, it's just like multiplying by 1. So if I want to know the number of molecules in 35 grams, well, again, start with what I know. 35 grams. I got to get rid of grams first, so 1 mole of water has a mass. This is where we finished on the one before. Now we're just going to do one more step. Do I know how many molecules are in 1 mole? I sure do. And it doesn't matter what the substance is. 1 mole of any substance has Avogadro's number of atoms, 6.02 times 10 to the 23rd. That never changes, okay? So I just multiply. So again, I take 35 times 6.02, divide by 18, and I get 12. And then I tack on my 10 to the 23rd. But again, I can't leave it as 12 times 10 to the 23rd. So I move this over, and I make this 1.2, which is proper. And because I made this number smaller, I make this number larger. So in 35 grams of water, there's 1.2 times 10 to the 24th molecules. And again, you would never be able to count that. It's mathematically calculated. Okay, how many moles of molecules? Moles, now this is a tricky one. They say moles of molecules, they're just looking for moles. If they want molecules, they'd say number of molecules. I know it's a tricky question. I hate it when they do that. But anyway, we're looking for moles. We have 146 grams of glucose, okay? And how I know this? Well, first thing I'd have to do is I'd have to find the mass of this. I'd have to take 6 carbon, which would be 72, and 12, hydrogen's 1, so it's 12, plus 6 oxygen. Add those together, and I'd find out the formula mass of glucose is 180, okay? That's just one of those things I know. I can't remember people's birthdays half the time, but I can remember formula mass of glucose. It's sad, isn't it? But anyway, so what I would do is I'd start out with what I know. I have 146 grams, okay? This is wrong, you guys. This step shouldn't be here. It should click right here. I don't know why this is on here, but so it'd be 146 over 1 mole. So I just take 146 divided by 180. Forget about this step. Okay, that's not supposed to be in there. And if you take 146 divided by 180, you'd get 0.18 moles. I'm going to have to fix these. These are the book ones, and I don't know. Sorry about that, but don't ignore this. This would be if we were trying to find molecules, but we're just going to go right here divided by this, and that's where you get your 0.18. If you did one more step, this is what you'd get. But again, moles of molecules, I guess they got fooled by their own rules. But if it's moles of molecules, then you're just looking at moles. So it's this divided by this, and that's where you get the 0.18. And again, I'll fix that later, sorry. Okay, what is the mass of 1.2 times 10 to the 23rd? Okay, we're going mass to molecules, 2 steps. Okay, formula mass of this, 12 carbon, there's 1 carbon, so that's 12. There's 4 hydrogen, so that'd be 4. So 16, and then there's 1 oxygen. 16 and 16 is 32. That is the formula mass of this. I would suggest you write that down and do it. I'm just doing it in my head because I know all these masses. And again, that's because my head is filled with weird things. I'm sorry, you guys. Anyway, okay, so we end up with this. How do we get this? Okay, start out with what we know. 1.2 times 10 to the 23rd molecules of this. And again, all the labels aren't in here because if I write in all the labels, you guys, then it doesn't fit on one line and then it gets all messy. Okay, so 1 mole of this substance or any substance has Avogadro's number of molecules. Okay, we're doing a compound, that's why it's molecules and not atoms. Okay, so now we got rid of molecules and we got moles, but the question wants mass. So 1 mole, and then I told you when you add all these together, you get 32. So if you take 1.2 times 32 and divide by 6.02, you get 6.39. And the 10 to the 23rds, they just cancel out. So 1.2 times 10 to the 23rd molecules of C3OH is 6.39 grams. Okay, so again, when you're going from molecules to grams or grams to molecules, you have to do 2 steps. All right. Okay, I think I have one more of these. Yeah, this one I put the answer on here so I know to quit. Okay, how many molecules in 4.12 moles? So if you're going moles of molecules, you guys, it's just 1 step. So write down what you know, 4.12 moles of HBr. And again, it really wouldn't matter what substance you have because 1 mole of any substance has Avogadro's. Since you don't have to find mass, it's not a big deal. But 1 mole has Avogadro's number of atoms, or molecules in this case, because it's a compound. So you take 4.21 times 6.02 and you get 25.3. Okay? All right, so times 10 to the 23rd. I'm going to move this over and make it 2.53 times 10 to the 24th. I think we did it right. Yeah, okay. All right, we're going to end there because now we're going to start talking about some other things. But again, we're doing the same things as we did before, but now you have to calculate the molecular mass first. And then once you find the molecular mass, then you can put them in these conversions like we did for elements. And that's what we talked about today. All right.